Welcome to the very next episode of The Lair. Today, we're going to talk a little bit about machine learning, how to maybe get started with it, what you can do with it, and it might actually help explain to many of you when you hear about COVID-19 that the models failed as to why the models had nothing to do with it. It was actually the data. And joining me today is still the reigning, defending, 5-time champion of the Captech University Researcher of the Year, and my good friend, Dr. Jason PIttman. Jason, welcome back.
Hey, it's an honor to be here yet again.
You know, I was thinking about our last talk, and which of course, maybe privacy should end, who knows, but where we're putting our energy. But really it was getting back down to, we're both kind of the anti-hero into everything. And so I'm trying to think to my, anti-hero Batman. Robin really wouldn't be a very good sidekick because I don't think Robin was an anti-hero at all. So
no, he was kind of the traditional hero spoil, if you want to look at it that way, to the strong Dark Knight anti-hero.
Yeah. So when, it's so many people are talking about COVID-19 and rightfully so. I mean, I've seen my own journey, amazingly emotional, even though I've got the data, but how I'm reacting to it. And the amount of people that were just thinking, the models suck, the models failed, we didn't have this many deaths, blah, blah, blah. And I was like, I think people don't really understand. We're using machine learning, and there's a huge difference between machine learning and artificial intelligence. And I went, well, what other anti-hero person could I bring on that might be almost as good looking as I am? I know you got that slick new cut, but and you are doing a tremendous amount of research in artificial intelligence over the last several years. I thought, who better to come on and start explaining a little bit about this, and then I'm even going to plan on doing a little demo from RapidMiner. Shout out to my buddy Mike Hilton for turning me on to RapidMiner because it's very, very easy to use, and maybe some people can start getting a little bit interested in machine learning. So,
yeah,
what's the difference between machine learning and artificial intelligence?
Well, I would describe the difference starting as machine learning tends to be classified as a sub-discipline within this broader field of artificial intelligence. And so when you start to juxtapose it against something like natural language processing or image or vision is typically how it's articulated. So you can have an AI, which is just an agent. It's a program. Typically it's defined as a program that behaves rationally. And so then rationally depends on the environment, and an environment gets embodied as the problem you're trying to solve. And that's that chain of language, right? And so then I can have an agent that tries to solve language problems by using natural language processing. I can have an image or a vision problem, like with autonomous vehicles. They have vision problems that they have to solve because they're navigating through sensors, which ostensibly are somewhat like our eyes, kind of, right? And so you use the vision image stuff for that. With machine learning, what you're trying to solve are really two types of problems. I have data, and I don't know what bucket to put it in, but I know what buckets exist or categories. And so I'm going to take the data and learn how to put it into the correct buckets. That's called a classifier, okay? And then you have what's called regression, which is, I think, what people normally think about. Roughly speaking, it's prediction. Here's information. Here's what I know based on what I was told, and it looks like this is the most likely outcome, or the least likely outcome, depending on how you want to look at it, because I think you want to talk about both sides, especially when you're talking about public models for health, or you're having these broad spectrum predictions based on some event like COVID. That's how you really think about it. Now, just to stipulate one thing, I think a lot of people misunderstand machine learning because they don't understand that there's a lot of moving parts to it. So there's the algorithms, which is more of like the way it comes from AI as a discipline. But there's also the data, which is really a data or a systems engineering problem. And I think this is maybe where you kind of want to focus this conversation around COVID is, so the machine learning is one thing. You can have perfect algorithmic implementation. We're talking about the programming of it, right? But if there's something in the data where it's not clean, it's not categorized correctly, it's not sufficiently complete, and you feed it into this algorithm, it's going to look like the model's bad, but like you said, it ain't the model's problem. It's the data problem, which is a data engineering problem.
Right. Because what you don't know is in any of the data, let's say as an example, you're collecting data on whether or not someone actually had symptoms. They could have lied. They could have been misinformed. They could have done anything. Like, think about it when we're filling out a credit application. When someone says they make 100,000 or 125, that could be enough to skew it if everyone did that. And so there's a confidence factor in the data.
Mm-hmm.
How does the confidence factor play in? Like, can you make adjustments for how confident you are in the data?
You can make adjustments. Often you'll see it presented as a variance. And I don't mean standard deviation in a statistical sense. I mean like this prediction is within this tolerance of plus minus %, right? And so sometimes this is why you'll see predictions in a positive and negative, not necessarily equal 100%, but you have to account for that plus minus. The real thing there, which you don't see in a lot of, at least the way the information is being presented to us in this case with COVID, is the assumptions, which you and I know from our doctoral training are massively important. Like you have to have a clear, transparent view of what assumptions you've made based on the data you're going to input to the system. And I think that's a big sore spot, at least for me. So confidence is one thing. Depending on where you got the data, who cleaned it, that's the data engineering layer to it. I don't know if trust is the right word either, but yeah, I mean, there's no way around having
just
assumptions.
Confidence.
Yeah.
Let's
no
say
way.
the confidence aspect.
Mm-hmm. Now you can compute a confidence interval statistically, depending on exactly what you're doing with your machine learning and the type of model you're using. Because there's one other type too, which is reinforcement learning. That's kind of a separate topic. Typically what people are looking at is either classifying things. Okay, I've taught my AI, if you will, or my ML, what apples look like. Now I'm going to give it images and have it classify the images into apple, non-apple. Perfect classification thing. Remember I had the drones with the EEG? That was a classification problem. How do I look at an EEG input and classify that as up, down, left, right? And then you can input that into a device and fly it. And regression is just prediction, which is really what a lot of these COVID models are regression models. And that's just simple statistical regression. That's the magic sauce for anybody that thinks otherwise with ML. And this is where it really differs in some ways from what people think AI is. Dude, it's just statistics. It's really all it is.
It's very true. And I mean, there's other models. I mean, you can do decision tree, you can do K nearest neighbor. There's a lot of different models. And that's the thing I think people don't understand, because like to me, I could do all of these models. And I think when I'm looking at a lot of data, and I would want to take, and I would use all, I wouldn't say all of them. I'd use a handful of these models. And the ones that give me, 99% on multiple models, multiple individual, when I go to back after I've done the training of the ML, if all of these are coming back and they're all saying 99%, then it's probably a good chance that is there and it's going to be 99%. But even still, I've allocated there's a margin of error from the sampling error, plus minus 5%, whatever. But also, there's a 1% chance that I was not going to be that, because no matter what happens, I have to allow for some other type of environmental change, such as, hey, maybe I broke my leg and I couldn't go to work for 6 months because I'm on disability, and now all of a sudden I went from 100% of my salary to 2/3. So that could mean some bills don't get paid.
Yeah. Well, and that's a great point. Like if you look at the three main types of classifiers, K nearest neighbor, support vector, and you can throw a couple other ones in there. yeah, they're all classification algorithms and they'll all classify things, right? But they don't all work necessarily the same way, and they don't all perform to the same level depending on what the data are. And this is why, for me, when I'm teaching AI, specifically machine learning, I teach it, and this is kind of my bias, right? Being more of a technician, right? It's about the data. You have to start with the data. And so, like, we know this from our doctoral training again. There's only certain types of data. And so you have numbers that are numbers that you can add or subtract and so forth and so on. And then you have numbers that are really symbols that stand for things. And this is where you get into like categorical data, which is great and easy for classification, versus continuous data, interval or ratio types. And you can do math with it, right? But that makes it a little more difficult to classify, but it makes it really good for regression. And so you have to start with an understanding of what the data are and this is what all machine learning lacks right now, is the idea of context, which is where these models really break down with COVID. Is there's no semantic attached to it, because ML can't do that. You need another field of AI for that. If you want a data model to be produced and then semantic to be assigned to it.
Right. So
me and you.
Yeah, and it's interesting because people go, oh well, you're not a medical doctor. I don't think they understand that you go through any doctoral training, you go through an aspect of how you're to perform studies. And we go through a piece of that as well that gets into protected classes, such as if we're doing any type of study on humans or animals, inmates, things of that nature requires additional oversight. And there's no difference in training as to whether or not you're doing a doctoral in computer science or you're doing your doctoral in pathology, biology, anything along those lines. You have to go through it. And if there's so much statistics involved in all of it, even when you're applying it to humans.
Yeah. I've found, at least in my career as an academic, the one thing we all speak in common is statistics, because there's not really, even the humanities, man, to be honest with you, there's no way around it. If you want to do any type of quantitative work, it's statistics driven, and that's the language we all share. And at least in the modern world, it's really getting expressed through machine learning.
And it is, and I think we're seeing it everywhere.
Mm-hmm.
So there's a lot of people that probably want to get into machine learning. What things could they do from your perspective if they're not heavy into computer programming, which I think Python's pretty easy for people to learn, and that's a good way to start. But if people aren't into computer programming just yet, what are some things that you think they could do to get involved in machine learning to have a better understanding, because it's happening all around us?
Yeah, no, it's a great question, man. Pathways are always an interesting thing to think about. And particularly with a field, see, this is the weird thing to me about machine learning. If you really think about it, you and I know it as business intelligence, right? If you go all the way back to like business dashboarding, even in its infancy in the early aughts, right? I mean, that's really a precursor to what we're talking about now. And so you don't deal with OLAP cubes in a database anymore. You deal with NoSQL, data lakes. It's not a completely foreign relationship, if you get the database pun. So that's one of the pathways. So if you don't want to program, let's say you don't want to write algorithms or implement algorithms, right? You can approach this from a pure data engineering standpoint, and where you're working just with, let's say, tables or files. And all you're doing is organizing data so that it can be consumed up into the algorithmic layer. That's one way to get into it. Another way to, interestingly enough, is through the networking, because all these systems have to be interconnected and they're not necessarily running on the same host because of the way functionality gets tiered to hardware. So you could be systems thinking, a system of systems becomes very important. And so what you and I, when we first started in tech, might think about as a systems engineer, that kind of role. There's an engineering part to just the systems to support all this stuff. Then you have the algorithm, which is the programming, but you also have the management of it too, because at some point, somebody has to assign some semantic to the output and interpret it. And that's not easy. In fact, it's way easier to get wrong than it is right.
I think you're spot on. And what I'm going to do very quickly is I'm going to take and provide an example for your first iteration. That it's people don't understand that really all I need is Microsoft Excel,
Mm-hmm.
and I can do a lot with it. Now I can even build. I could take Python, JavaScript, and start programming, get a lot of stuff in Excel, because really all I need are the columns, which are going to be your data classifiers, and then the data to fill it out.
Yeah.
So I'll provide a quick demo of RapidMiner, just because, well, it's easy to use and it's free for up to, it's like 10,000 rows, 10,000 columns. And the data that I'm going to use is when I took a big data class at University of Michigan Ross, we had some data from, it's just old German credit card data. Don't know from which company, but it's a small sample set. But what it does is it gets us into very quickly and easily as to how powerful it could be. And I hope some of the people that are wondering about these data models, they may start to understand it, because there's two tails to this.
Mm-hmm.
That was also a statistical pun. So I'll do a quick a quick demo of this. It's not too difficult. Hopefully, can you see my screen now, Jason?
I can.
Probably.
Oh, now I can. Yes. Yes.
All right.
There it is.
So let me get into good old RapidMiner, and it's very simple to use. And all we're going to do, and I've done this a little bit. RapidMiner Go is it's pretty much free, and you could get into some crazy stuff, and it's all in the cloud, which makes it even easier. So all you need is a Microsoft Excel spreadsheet. I'm using one that's already been pre-built, and it's the credit data. So what is going to happen? We're going to upload this, and as you can see, there's all these different rows, and each one of these things means something new. Not new, but it means something to how someone they believe is important to make some type of decision on. Do they have a new car or used car? How many? How long do they have a credit history for? What's their age, job, employment, so on and so forth. And at the very end, the response, which is also important, because this is all historical data, because we can't make decisions about the future without having something to go by. And so that is important. 1 meaning they were approved, 0 not. Now this is all the data, and we're just going to go and tell it, hey, what is it that we want to choose to predict? Now that's the other part. Not only do you need to have the data, it's what are you trying to predict? What are you trying to answer? What is that thing that's important to you? And when this is for making a credit decision, it's probably not important for you to predict whether or not they have a checking account, because that doesn't really matter. It's something that you're using to support it. We're worried about the response. Like in this case, which do we want? Now we can choose. The value is what's more important to predict correctly, the rejection, or in this case, the approval. And in this case, I want to do the approval. So we'll go through and we'll do a click next. Now the great part is it comes out and it tells you some great stuff. And so it says, hey, these are some things that it probably doesn't matter. Like the OBS is just the object number, and it says high IDness, meaning, hey, it's something you don't want to have to worry about. So it's pretty good in how you could do things, whether or not it's the data objects appear to be correlated or not. And you can go through and it's some fun stuff. Maybe you want to get a little bit more into it, but it does a pretty good job of telling you, hey, like what's correlation? Well, you can read the question mark. How closely do the values resemble target values?
Mm-hmm.
So Jason, do you want highly correlated values?
It's a good question, because it goes back to what you just said. A lot of this depends on the question you're asking. Typically what you want to see, I guess, if you're looking at I was going to say FICO credit information, is you want high correlation. The more something's correlated, you can't say that one causes the other, of course, but you can say that at least they co-vary in certain ways.
Right. So we're going to go through and we're just going to say, okay, you've got multiple different things. It doesn't take a lot of time. Do we want decision trees and simple linear models? We can do quick prototyping, higher accuracy. In this case, we're going to go through and we're just going to do easily interpretable. Now you can get through the quick advanced settings, and like there's a ton. These when we talk about models, these are what we're talking. Whether or not be it generalized linear, logistic regression, fast large margin. I do want logistic regression because, well, that's my favorite. But you can get in. These are basically the models. And well, the algorithm supporting the models, I would say.
Yeah.
But I happen to like. Go ahead.
Sorry, I was just going to say, and so everybody knows, this is what we were just talking about a few minutes ago when we were talking about there really are, broadly speaking, two types. There's classifiers and regression. Classifiers categorize things or classify things, and regression make predictions.
Right. So you could choose as many of these as you want. I've got them all on just to kind of show, because these are the things. We're going to run some analysis. Now, during this analysis, what's happening is it's taking a randomized sample of the data. That's your training data. And it's going to go through and it's going to figure out, hey, what's the thing? So after it gets its randomized sample, it's going to take a portion of that and it's going to put it back into the model, and it's going to tell you how accurate it was based on its training. And so it's starting to pop up now, and you can see like how many seconds it's done and finished. And so the generalized linear model, when it takes back, it says, hey, I was right 74% of the time. Here's logistic regression, 74%, and it'll keep on going. Decision tree is 70.69. Where's my logistic regression? There it is. So 74.81. So I think they're all done. All done now. Perfect. So now I have this, that is now my model. I am now going to apply my model. And I'm going to say, what kind of analysis do I want? In this case, I want to, because I've done this a couple of times, I want to predict my credit data. So I'm predicting a response in credit data. But which model do I want to use? I like logistic regression, because you can only really do this one at a time.
Right.
And I'm not sure if the other more advanced ones allow you to do multiple at one time. I don't know. Doesn't matter. But I've got everything in here just like it is, but I don't have as many. I've just got a handful, 10 particular ones. And I'm going to predict what's going to happen. I have no idea. Could be anything. But it's taking that model that we've now created, and it's going to give me some responses. And so here it is. So when people start talking about, hey, the model failed us, no. So here's a great thing. So for this new record one, there's an 84% chance that it's going to, basically, I'm going to say that they're going to pay their bills on time, but there's a 15% chance that they're not.
You're right.
And you get this for every record.
Yeah, because those two columns correspond to your categorical responses, 1 being yes, 0 being no, right?
Right.
Yep.
So this is machine learning. That is exactly when we take this with someone coming into contact. So when we start referring to COVID-19, did our models fail us? I argue no. The models had nothing to do with it.
Yeah, I would tend to agree. You see the same. There's a similar argument in social media about the algorithms that are used to, like, let's say, bubble some content up to be more visible or suppress it. And some people think those models are biased. Well, if there's not a bias in the model, there's a bias in the underlying data, or there's a bias in the interpretation or the semantic assigned to it, which is a human problem, because machines are not capable of doing that yet, right? The model's the model. Regression works the exact same way every time you run it. And as long as there's not it's like crypto systems, right? As long as there's not a flaw in the algorithm itself, which we know there's not, or the implementation of it, which chances are there's not, could be, but chances are there's not, then there's only two things left. The data you're feeding in and or the data you're applying the model to, something's inappropriate, or it's your interpretation.
And that's what a lot of it is. I mean, think about this in the greater context. I can't be 100% correct in my prediction. I can only know that I was 100% correct after we have observed the event.
That's right.
Then I know.
Well, you know, and a beauty of human intelligence and cognition is that we have these abilities wired into us, right? And you and I are here because our ancestors were very good at it, very good at rapidly incorporating historical data into their current world model and acting appropriately. The people that stood around trying to guess whether that was a saber-toothed tiger or not.
Yeah, it probably didn't work out very well for them.
No.
I would imagine. And that's the thing, like with the data, when we get it, you know, it's an observation. We've made an observation. We have now written some things down about that observation in order to make it human readable and understandable, because that's, you know, we have to make it to where we can digest it and then we can make some type of interpretation from it. And there's a lot of things, and the more things you can put in there, you can see whether or not it mattered or not. So when at least to me, when I'm looking at this, I go, why do we think the data from China wasn't good? Why do we think it was bad?
Right.
We have no idea. It's still data, and we can put it in there. Now maybe we'll know when all of a sudden you put in bad data into your model. And so if your model was, you know, most of the times the people, when they're looking at models, they're looking for something that's, you know, that it's well into the 90 percentile. Like we're not trying to, you know, predict whether or not, you know, the chicken's going to cross the road, so to speak. I mean, they're trying to predict deaths. That's a serious thing. So they're not looking at a model that's only going to give them 70% accuracy. At least I would hope not, but I haven't seen their version of RapidMiner come out and go, okay, our model, after we've trained the data, was a 95. And folks, they're doing this constantly. Every time they're getting this data, they're putting it back into it and seeing how much it changes. And I would imagine they've got millions of records.
This is also where, so people understand too, I think I remember having a very distinct conversation during our doctoral program about in statistical analysis, it's called saturation. In machine learning, you call it overfitting. I mean, you can get to a point where you're stuffing too much data into it because you're inducing a bias through the data. The model itself is still the model. It doesn't change necessarily that way. And that's the thing with what's going on is, I'll go back to this. Often, and I think you'll agree with me, when you're working with technology and you feel like something magic is going on, that you don't understand why an outcome is an outcome, it's because you don't know everything yet. And that's a good place to be once you recognize it, because then you can go find out what's going on. And so you see this like with COVID. To this day, because of how novel it is, people still don't understand all the underlying genetic preconditions that impact how that virus affects you. And so you can at me and disagree all you want, but the biological facts are that there's a genetic code associated with Wuhan and the citizens that's different from the people in Western Europe, that's different than the people that live here in the US. Generally speaking, the genetic makeup is sufficiently different. That's why we're different, okay? And so until you understand all those factors, all the preconditions, vitamin D, I read a report last night, seems to have a lot to do with it. How deficient you are can impact how severely the virus affects you. Well, the model has to be updated because that's a new data element. It's not the model's bad.
Absolutely. And this is where, you know, and I've been reading a bunch of articles out there as well. It also has to do with the amount of times we have put ourselves into different environments, because then we become exposed to other, viruses, bacteria, all that kind of fun stuff. And I'm this is not the kind of doctor Jason and I are, but we know how to read the data.
Yeah, well,
we
I
know
mean,
how
if
to
nothing else,
interpret data.
right? If nothing else, I know how to add a column to a spreadsheet, and that's really all you're talking about, right? If I want to include vitamin D deficiency into my machine learning model, if it didn't exist before, that's a new factor. You're honestly in a straightforward way just adding a column to that RapidMiner table.
Absolutely true. And this is so one of the other things that we did in my big data class, and I've been doing it for years. We took a look at heart attack. What's the probability of having a heart attack? Well, outside of knowing people's diet, which you would have to study for a very long period of time, if all you had were age, sex, meaning, are you biologically male or female, forgetting about the whole aspects of all these other things you may want to self-identify as from a genetic standpoint, male, female, the number one contributing, factor is age. The longer you live, the higher probability you're going to have a heart attack.
Yeah.
So it's something that, it's just because you're around longer. And it's no different than the wear and tear on your car. You drive more miles, you've got to replace the tires at some point. So,
well, and see, this is part of it too. We were talking about this in the pre-show, is the lack of and it's really an education problem. The lack of people's general ability to understand numbers and to interpret statistics. So, like, here's one that kind of riffs off what you were just saying. From the moment I'm born, I have about a 1% chance of making it to 90. Right? From age 1 to 90, there's about a 1% chance that I'll make it. But if I get to 89, it's not 1% that I'm getting to 90, right? There's a really strong, high probability, right, that I'll get from 89 to 90, but not 1 to 90. And that's because of the scope of factors that are involved along that way, right? And it's two different models. It's not the same model anymore, right? The model from 1 to 90 is different than the model for 89 to 90. And just like heart attack, well, yeah, because there's factors that are sloping as you increase in age. Yeah, yeah.
Right. Yeah, and so here's another way in which I have used things like RapidMiner. Stock predictions. Whether or not I want to choose to invest in a stock. All the data is available from like NASDAQ, New York Stock Exchange. Now, I can't do a bunch of different ones, but what I've done is I've taken this data and I've put in some stocks that I find, at least the company's interesting. And so I put it in there to predict what I believe the stock price is going to be. And if it gets to a point where I think it's something I want to invest in, like because of my models, and I'm certainly not going to show that because, probably get kicked off YouTube, and I'm probably, well, I'm not licensed to give that kind of advice. But you could do this. And once that happens, then I go and I take a look at their financial reports and see, does it make sense for me to invest? I've used my machine learning tool, and it's important, it's a tool, to determine whether or not I should investigate a company to make a decision to invest or not to invest.
Yeah, right. Yeah, if I got 10 grand and there's a 75% chance the stock price is going to go up, that's different than if I have 10 grand and the stock price is 25% likely to go up or 90% to go up. And the model and its outcomes can't tell you yes or no. It can tell you 25, 75, 90. And as you said before, that means there's still 75% chance that you're wrong when you're 25% chance right, 90 and 10, so forth and so on. And dude, think about this. If you have that feeling that you're surrounded by idiots, well, first of all, maybe you're the idiot. But second of all, when you talk about statistical distribution, think about how many people you encounter. Dude, I don't think you'll encounter 1 million people in your lifetime, like in a meaningful way, right?
Right. Because if you fly all over the place, you could come across 1 million people, but you're not going to meet 1 million people.
Right. And so you're well under 1% of the total just U.S. population. It's completely conceivable that the pocket of space you occupy, because you're not leaving it, is completely dominated by idiots. Maybe that's where they're all located. It's idiot city. I don't know, but it's possible statistically.
Absolutely, it is. And I think, what I really want to stress to to everyone out there, that remember, machine learning, AI, it's a tool to help us, to inform us of future decisions. The tool, the model, it didn't make the decision for us. We're using it because we are trying to make a good decision. And that's all we can really hope for. It doesn't matter necessarily to me whether or not, the presidents or the governors, if they're closing or not closing, they're using this type of data because I don't believe a nefarious act is occurring. I don't think anyone wants bad things to happen. They're trying to do the best they can, and they're using statistics to help them because they don't want people to die. Uh, and those that are on the one side saying the models failed, I hope you learned they didn't. And for those that say the models were right, I hope you can see they weren't, yes or no, because it has nothing to do with it. It's all probability. It's a risk.
Yep.
And it's either, it's like predicting the weather. When they say it's extremely likely that it's going to be sunny today, they probably mean 95%. Because there's a 5% chance the wind could change and there's now cloudy. So they weren't wrong, but we can't talk in those terms. We're people. No one, I'm not going to say, I'm not going to say hey, Jason, hey, there's a 95% chance that we're going to have a good show, but there's 5% that's going to suck.
Right. And that 95, and then 95%, well, the whole model, but the outcome specifically is based on how many shows have you had, how many were good, how many were bad, what day of the week did you have the show on, did you have enough coffee yet? There's all these factors that fit into that model that are columns in that spreadsheet, so to speak, that have to be computed. Here's the best way I think I can illustrate this to people. This is my parting thought, perhaps. The introduction of machine learning is to the field of statistics and data analysis what the transition from a simple Casio calculator is to a Texas Instrument TI-84. You're performing a massive upgrade in what you can do with that tool. That doesn't mean you can understand it if you don't know how to use it, right? Because 2 + 2 is still 4. But if you're typing in the wrong numbers, let's say 1 + 1 and expecting 4, that ain't the calculator's fault, bro. That's your fault.
Well said. Jason, again, I appreciate you coming on. Hopefully some people learned a little bit more about machine learning. The last time you were on, we talked about what was next. And what was next, of course, is it was only a few weeks ago. But I hope you are, making progress on your next book. Yep. Because, hey, part of the reason why I do this show is to help my friends have a recording of what their goals are. And this way it gets kept.
That's right. It's forever and ever on the internet.
Right. It is forever out there. So I don't need to ask you what's next yet. So there's nothing you have to pay Dr. Ford this time, because it has your goal was for the end of the summer. Yeah. Or, so we'll keep checking back in on the progress. Again, my friend, thank you so much. Hope to have you on again soon.
My pleasure, my honor. Take care, everybody. Bye.